if you place a 37-foot ladder against the top of a building and the bottom of the ladder is 22 feet from the bottom of the building, how tall is the building? Round to the nearest tenth of a foot. Okay, because my drawings suck, and they do, I'm going to take a building and just, I'm going to use some technology to draw the building. That is my building right there. And then I'll use some technology to draw the ladder as well. So the ladder is, it says that the ladder, it's against the top of the building, so the top of the building, and then it's going to go all the way to the ground. So it's going to give me something like this right here. All right, and then we got the ground, of course. I'll make it green because we'll pretend like it's grass. And this is kind of the picture that we get from this. Do you have to draw a picture? Of course you do not, but I did. So let's look back at the information, right? So it's a word problem. You may need to read and reread these several times. But it says that the ladder itself, which is the purple line right here, there's my ladder. Ladder, I think I spelled that right. But the ladder is 37 feet long. So I'm gonna label this as 37 feet. There we go. The next length that it tells me is that, let's see, the bottom of the ladder, there we go. The bottom of the ladder is 22 feet from the bottom of the building. That is from where the ladder touches the ground to the base of the building. That is this length right here, which is 22 feet. Now those markings are for feet. What I see then is that I am now missing the height of the building, length, and even though they didn't say this, it definitely will create a right angle right here, right? So since it's a right angle and I have now these two lengths, I can see that one of the lengths that makes up the right angle is this leg length of 22. You know, we don't know this leg. But then the ladder itself is the hypotenuse because it's the triangle here, and the triangle length that is not making the right angle is the hypotenuse, 37 feet. So there's my Pythagorean theorem. Again, one of the legs that I have is 22 feet. It doesn't matter which one you say is which. I'll make it this one just to change it up a little bit. And then my hypotenuse is 37 feet. So I've replaced those. Now I have leg squared plus 22 squared equals 37 squared. So we're going to have to go to the calculator to get this solved, right? Well, unless you can do that in your head, which is pretty impressive. I just can't do it. So 22 to the power of 2, enter, I get 484. So that's from that leg right there, 484. And then 37 to the power of 2, or squared, showing 1,369. Okay, so now I've got a leg squared plus 484 going to equal 1,369. And from here, we're just looking at principles of equality. So that is what I will do. Next up, what we need is to take that leg squared and just be able to drop it like this so that we can find out what that leg to the power of 2 is going to equal, meaning that we don't want the 484 there added to the leg squared. So I'm going to subtract 484 from both sides. Minus 484. And once again, you could do this on paper, maybe in your head. I'm just going to use a calculator for that. So 1,369 minus 484. And it says that leg to the power of 2 is going to be 885. Nice. Well, the last thing I need from this is not just leg to the power of 2, but I need just a regular leg to equal something. So I'm going to get rid of that power of 2 by square rooting both sides. So in the calculator, square root 885, enter, and I get this number. This one right here, of course, that would be in feet, but the last thing it says is that we need to round this to the nearest foot. So again, I'm going to have a leg. It's going to equal something, but I've got to take that 29.74894956 and round this to the nearest tenth, which is where the 7 is. The 4 is less than 5, so the 7 is just going to remain a 7, and I end up with 29.7. Once again, labeling this in feet. And that's it.